There are more than 200 known moons drifting through our solar system, and more are being discovered every day. Some have bizarre shapes, icy or molten surfaces, and hidden subsurface oceans that may even host life as we speak. Today's advanced technology also allows us to revisit old mission data and create stunning new images, providing fresh discoveries about these moons. Join us as we take a closer look at real images of our solar system's moons, some of which you may not even know exist. Pluto and its moons. You might be surprised to learn that Pluto, classified as a dwarf planet, has 5 moons. Some are so distant that they're hard to photograph. Pluto's largest moon, Charon, was discovered on June 22, 1978. It's about half the size of Pluto, measuring 754 miles across. And Pluto and Charon together form a double dwarf planet system, orbiting a shared point in space, rather than one orbiting the other. When you compare the technology available 40 years ago to what we have today, the difference is extraordinary. In July 2015, NASA's New Horizons spacecraft flew over Charon, revealing mountainous terrain and a canyon stretching more than 1,000 miles, 4 times the length of the Grand Canyon in the United States, and twice as deep in some areas. Neptune and Triton. Neptune has 13 known moons. Among them is Triton, first observed up close when Voyager 2 flew by on August 25, 1989, capturing a series of images. Triton stands out because it orbits in the opposite direction of Neptune's rotation, unique among large moons. Even more intriguing, Triton features massive ice volcanoes and geysers that sometimes spew water, ice, and ammonia, leaving large impact craters. The biggest crater on Triton measures 9 miles across, and scientists believe there may be vast oceans of liquid water beneath its frozen surface, potentially harboring some form of life. A new mission, called Trident, is currently in the planning stages to explore Triton more thoroughly. Eventually, millions of years from now, Triton will drift so close to Neptune that tidal forces will tear it apart, likely creating brilliant new rings around the planet. Uranus and its unusual moons. Currently, Uranus has 27 known moons. Among the most noteworthy is Miranda, whose surface features some of the strangest terrain in the solar system, including vast fault canyons 12 times deeper than the Grand Canyon. Another moon, Umbriel, is the 3rd largest Uranian moon and appears blue because of its icy, rocky composition. Since Uranus orbits the Sun on its side, the planet and its moons undergo extreme seasonal cycles. Each pole spends 42 years in complete darkness, then another 42 years in continuous sunlight. Would you like to see a video about Uranus and Neptune? Let us know. There have been some intriguing recent findings about these ice giants. Saturn's many moons. Saturn's orbit currently hosts 82 discovered moons, so we'll spend a bit more time here. Pan is a tiny inner moon, only 8.6 miles across, with a very odd ravioli-like shape that was first observed by Voyager 2 in 1990. Another of Saturn's innermost moons, Atlas, is equally peculiar and often compared to a UFO. NASA's Cassini spacecraft captured stunning photos of its flying saucer shape, about 19 miles in diameter. Hyperion, another Saturnian moon, looks like a giant space sponge, likely a fragment of a larger ancient moon destroyed by an immense impact in the early solar system. Meanwhile, Mimas, famously known for its resemblance to a fictional moon-shaped space station, has a massive impact crater spanning 1/3 of its diameter. This crater measures 80 miles across, with walls nearly 3 miles high. Scientists believe the collision that created it almost shattered Mimas completely. Saturn's 6th largest moon, Enceladus is particularly special. Images from Cassini show jets of water ice erupting from its surface and spraying into the moon's atmosphere. By flying Cassini through one of these icy vapor plumes, researchers detected salts, hydrogen, and both simple and complex organic compounds, ingredients that fulfill all the basic requirements for life. This discovery indicates that Enceladus's subsurface ocean could be hospitable to living organisms. We haven't forgotten Titan, Saturn's largest moon and the second largest moon in the solar system. Titan has a nitrogen-rich, Earth-like atmosphere, and its surface features what appear to be dry river networks and lakes of hydrocarbons. Thanks to 13 years of Cassini data and modern imaging technology, we have breathtaking new images of Titan. It's the only place in the solar system besides Earth known to have liquid on its surface, as well as a host of complex chemicals essential for life. NASA's forthcoming Dragonfly mission, a drone featuring 8 rotors, aims to take full advantage of Titan's thick atmosphere and low gravity to explore multiple sites for signs of life. Jupiter's incredible moons. Jupiter also boasts a large family of moons, over 80 by some counts. Its biggest moon, Ganymede, is the largest in the entire solar system, even bigger than planet Mercury, earning it the nickname King of the Moons. Another Jovian moon, Io, is the most volcanically active body in the solar system, with around 240 active regions. A remarkable image from the Keck 2 telescope in Hawaii captures a massive eruption covering roughly 11 square miles, ejecting material far into space. NASA's Galileo spacecraft also snapped dramatic shots of volcanic plumes, including one enormous eruption on the edge of Io and another in mid-image that casts a reddish shadow. Europa is another moon of Jupiter that intrigues scientists because it may also host a subsurface ocean containing more water than Earth's oceans combined. We know the water is salty because Galileo's magnetometer detected something conducting electricity beneath Europa's icy crust. Jupiter's immense gravity tugs on Europa, creating internal heat that constantly fractures the surface ice. Reddish brine seeps upward through cracks, like a giant jigsaw puzzle. All this suggests Europa might have conditions suitable for life. Callisto, the outermost of Jupiter's 4 large moons, measures around 3,000 miles across and is likely as old as the solar system itself. It shows no volcanic or tectonic activity. It's geologically dead, and is one of the most heavily cratered objects in the solar system. Images from Galileo reveal a cosmic relic that has endured since the dawn of our planetary neighborhood, Mars and its moonly fates. Moving inward, our nearest planetary neighbor, Mars, has 2 small moons. Deimos measures only 9 by 7 by 6.8 miles, and our best images of it come from the Mars Reconnaissance Orbiter. Phobos, the larger Martian moon, orbits so closely that it completes 3 full orbits of Mars in just one day. Its most notable feature is the Stickney crater, 6 miles across. However, Phobos is gradually spiraling closer to Mars at about 5.9 feet every century. In roughly 15 million years, it will collide with the planet. Earth and its vital moon. Back at home, Earth has just 1 moon, and we're the final planet, moving outward from the Sun, to actually have a moon. Ours is the 5th largest natural satellite in the solar system, and the only celestial body besides Earth where humans have set foot. Our moon plays a crucial role in stabilizing Earth's axial wobble, making our climate hospitable for life and controlling ocean tides. Its light and dark areas indicate that it once had a molten crust that has long since crystallized. Scientists believe the moon formed when a Mars-sized object collided with Earth, 4.5 billion years ago, creating a disk of molten debris that coalesced into our lunar companion. Interestingly, Earth's moon is slowly moving away from us by about 1.6 inches per year. As a result, our planet's rotation also slows. But in 4.5 billion years, when our sun expands into a red giant, solar drag may pull the moon back in, tearing it apart once it crosses the Roche limit, about 11,470 miles above Earth, and forming a bright ring system around our planet. Fortunately, that's far beyond our current worry. The Sun, our stellar anchor. At the center of our solar system sits the Sun, a colossal sphere of burning plasma 865,000 miles across, large enough to fit 1 million Earths inside. Humanity has studied it for millennia, yet there's still much to learn. Modern observatories and spacecraft are gathering ever more detailed images and data, helping us unravel the Sun's mysteries and predict its outbursts of space weather that can disrupt satellites and power grids here on Earth. On January 30th, 2020, the Daniel K. Inouye Solar Telescope in Hawaii captured its first high-resolution images of the Sun's turbulent surface, revealing a pattern of boiling plasma.